In this video, we're looking at parallel and perpendicular lines. So these are, I guess, two types of special lines. So basically on a graph, you need more than one line. So in order to have lines with an S, a plural, you obviously need to have more than one. So I'll give you a quick example of what parallel lines look like and what perpendicular lines look like. So I'm just going to pause and open up my calculator. Okay, I thought it would be a good idea to actually show you me creating these graphs. So when you turn on your calculator, you get your home screen. There's a calculator and a graph here. You can go to either of those two, but I'm a stickler for these ones. So I'm always probably going to choose this one here. Okay, remember that this part represents y equals. So in maths, usually we don't refer to lines as lines, we refer to them as functions. So this is f represents function 1, where x is your variable. But you just need to remember at this point in time that it just means y equals. Okay, so let's do one line. Okay, so 2x plus 3, there it is there. Okay, doesn't matter what I chose because I'm just showing you what perpendicular lines look like. Now the definition, parallel lines. The definition of parallel lines is that you have the same gradient. So if this gradient is 2, that means a line parallel to it is also having a gradient of 2. So I can do anything here, 2x plus 4, 2x minus 10. Okay, they'll all be the same. So we might do a minus. Okay. And you can see there we have parallel lines. And remember, the definition of parallel lines is that they never cross. So I can keep doing all these, remembering that your even 2x, your lines will never cross. They have the same gradient. Okay, so there's a few there. Okay, so they all have exactly the same gradient, which is 2. Okay, but they have a different y-intercept. Okay, so you can see here all our lines are parallel. Now, just so you don't get confused that parallel lines have a gradient of 2, I'm just going to show you now. So if we had maybe negative 4x, there's our graph. Let's draw another one. Negative 4 is our gradient. Whoops, plus 3. Okay, so there's another one. So just remember, the definition of parallel lines is they have the same gradient. So whatever the coefficient of x is, as long as it's the same for every line, it would be parallel. Okay, let's go back to here. So the key ideas, which you should put into your band reference, parallel lines have the same gradient. Okay, so here we've got 2 lines and we can see the coefficient of x for both of them is 3. Okay, so they're parallel because they have the same gradient. They have a gradient of 3. Now, if I just scroll down for now, because perpendicular lines are a little bit harder. Okay, decide whether these are parallel, perpendicular, or neither. So let's just go through a few and see, whether they're parallel. Okay, question A, we have y equals 3, x minus 1, and y equals 3, x plus 7. They have the same gradient, therefore they are parallel. Question B, okay, I'm not going to read out the equations, just the gradient. So the gradient of the first line is a half, the gradient of the second line is a half, so they have the same gradient, therefore they are parallel. Question C, gradient is negative 2/3 and the second one is 2/3. They are not the same. This one is a negative, this one's a positive, so they're not parallel. Okay, can you see any just by looking? Okay, I can't. These ones down the bottom that aren't in the form y equals mx plus c, you need to get them in the form y equals mx plus c before you actually decide whether they're parallel or perpendicular. And we'll cover that in a second. All right, let's go back up to perpendicular lines. Okay, so the brief definition before I get into the example means that your perpendicular lines make a 90-degree angle. So they make a cross, basically. And when you multiply the two gradients together, you get -1. And here's another rule. The gradient of one line is equal to the negative reciprocal of the other. Now, I'm going to focus on this one for most of you, but if you're planning on going into methods, you might understand this as well. So I'm going to show you on your calculator how to easily find the other gradient. But before we do, let's have a look at what these parallel lines actually look like. Okay. Now, let's just do a basic one. Let's do 4x. Okay, there it is. And I know, just because basically I've been teaching for so long, that, oops, what did I do wrong? I forgot to put in the x. Here I am getting distracted saying I know how to do things. Okay, so if we have a look at our two gradients, here we have 4. And your other gradient, so the gradient of the red line, is the negative reciprocal. So what it means by reciprocal is we just flip it. Okay, so this is basically 4 on 1. The reciprocal becomes 1 on 4. And we just change the sign. So if one's positive, the other one has to be negative. Now, if you're a bit unsure how to do that, and I'm going to show you this again in a sec. So, sorry, I'm just getting a little bit distracted. Okay, so you can just use solve. Okay, now I know that 4 times something, say x, is equal to -1. Okay, so if we go back to the definition of perpendicular lines, the multiplication of your two gradients is equal to -1. So that's what I'm doing here. Okay, one gradient times another gradient is equal to -1, and then we just go comma x. Whoops, and there's your other gradient. Okay, so just remember, okay, let's say our gradient for one line was -2 this time. So the gradient of one line times the gradient of the other, and if you like, you can use m, because we use m to represent gradients, is equal to -1, and then we go comma m. Okay, so that means the other gradient has to be 1/2. Now, for some of you, you'll be able to see straight away what the other gradient is, but I strongly encourage you to use this formula. Okay, and we're going to use that when we go through solving some of the questions. Okay, so let's go back to our key ideas. Okay, so there's examples on here. I'm not going to go through them. Okay, you can read through them as well. Okay, so let's have a look now. Before we decided which ones were parallel, let's have a look at which ones might be perpendicular. Okay, so remember it's the negative reciprocal. So I'm going to actually do some writing here. Let's look at C, because remember C wasn't parallel. A and B, they were parallel, but C wasn't. And I don't know whether this is actually working. Can I draw on here? No. Okay. That's too thick. Just bear with me for a sec. Okay, sorry. I just needed to plug back in my tablet. Okay, so where were we? Question C. So here we have a first line, which has a gradient of -2/3, and this one is 2/3. Now, I know from experience, and eventually you may get to this point, that I can see that this is a negative and this one's a positive, which is what you want for perpendicular lines, but you want the reciprocal. So this fraction here is 2/3. The reciprocal, so when it's flipped, becomes 3/2 or 3/2. So these aren't perpendicular, nor are they parallel. Okay. And if you're unsure, you can just go to your calculator and type it in. So negate, and if I just go to control and bring up the fraction, so 2/3, when we multiply that, so -2/3 when multiplied by +2/3, do I get -1? No, I don't. Therefore, they're not perpendicular. So you can check them on your calculator that way as well. All right, let's have a look at question D. So the gradient of this line is -4. The gradient of this line is 1. Okay, so one's negative, one's positive, which is fine, but they're not the reciprocal of each other. So they're not perpendicular. Okay, question E. So we have a gradient here. I'll just get my pen. Okay, it's -3/7, and this one is 7/3. So we have one negative and one positive. This fraction here is 3/7. This one here is 7/3. So it is the reciprocal. Okay, so this one here in E, these two lines are perpendicular. So to check that on your calculator, let's get the calculator up. You can do negative 3/7 times 7/3. And if I get -1, it means that they're perpendicular. So they're -1. We can also graph them. Okay, so I'm just going to get rid of the lines I had before. So the first one, I can't even remember. What was it? -3 on 7.5. Now see how I've written the fractions? So you can use just the divided sign in between. Just make sure when you look at the equation that it's actually written the way that it should be. Okay, so there's one line, the red one, and to do the other one, just press tab. Your tab key is here, okay, just in case you've forgotten. And the other line, what was it? 7/3 plus 2. Okay, we'll get rid of that. 7/3x plus 2. Okay, and I can see, well, that they're pretty much perpendicular. I don't have, my protractor out to see if they're actually at 90 degrees, but we've checked there on the graph, and we've also checked there by calculating them, and we've also done it by sight, knowing that one is negative, one is positive, and 3/7 when flipped does give you 7/3. All right, so you can have actually, before we do that, let's have a look at, let's skip down to question J. Okay, so J, we have 3x minus y equals 2, and x plus 3y equals 5. So you need to, before you decide on what the gradient is to actually use your calculator, and I might just move that so I can see the equations. Now remember, solve in maths is your best friend, really. Okay, so we type the equation 3x minus y equals 2, and because we want it in the form y equals, just comma y, and we get y equals 3x minus 2. And let's do the other one. So x plus 3y equals 5, comma y. Remember, we're doing question J here. Okay, if you have trouble reading that, remember you can just do expand and then press enter. Okay, so I can see here that the gradient, this one's quite a tricky one actually. Come on, I need my pen anyway. So the first one, we have a gradient of 3, and the second one is negative, and it's written as negative x on 3, which is the same as negative 1/3 x. Okay, so your calculator just doesn't draw it that way. Now I know straight away they are perpendicular, but if you're unsure, you can just do 3 times, so 3 was this gradient, times negative 1/3 and I'm going to put this in brackets. So it reads it as a negative sign, not a minus sign. Oh, I could put it in the circle. Okay, so we get -1, therefore they're perpendicular. You should be able to read whether they're the same. We don't have to do what you would get if they're the same, because obviously if one is 3, the other one's 3, then you know they're parallel. It's only when they're perpendicular that you can multiply them to see if it is equal to -1. Okay, the next, actually we might stop there and I'll do the, oh no, we'll keep going. Just because, and I hope this is still recording, because I moved, let's move that. Okay, so question 2, I think it's question 2, yeah. We have, it's harder. Okay, so we have to find the equation of the line that is parallel to and passes through 1, 5. Okay, and this is where I've got to do a bit of working out. So we'll do question A, which is usually always the easier one, and then we'll do some hard ones. So question A, first of all. Now, we always identify what the gradient is. So the gradient of this line is 1. Okay, if there's no number there, then it's 1. And it's passing through the line 1, 5. So we have the equation of a straight line is y equals mx plus c. And we just substitute these 3 values in. Okay, so this is x and this is y. So y is 5, m is 1, x is 1 plus c, and then we just solve for c. So c is equal to 4, and then we just put that back into our equation. Okay, so let me just change the colour here. So just recapping what we just did, from the question we know the gradient is 1 and we've got a point here, 1, 5. We use the equation of a straight line, y equals mx plus c, and we substitute in the value. So y was 5, m is 1, x is 1, and c is what we're solving for. We said c is 4, okay, so we know c is 4. We put that into our equation, and we know the gradient is 1. So that's a number that goes in front of the x. So the equation that is parallel to y equals x plus 3 and passes through 1, 5 is y equals x plus 4. Let's get rid of that. Back to blue. Okay, let's do a perpendicular one. Okay, because they're going to be harder. Okay, so perpendicular to 2x plus 3 and passes through 2, 5. So for this line, the gradient is 2. Okay, and we can say the gradient of the first line is 2. But what is the gradient of the second line? The line that we're trying to find, and that's supposed to be a question mark. Now remember what I said before, when you multiply your two gradients, you get -1. Okay, and it's probably a good thing that it's still on there. I'll move you over. Okay, so our first gradient was 2, so we can just go solve. First gradient is 2. We don't know what the second gradient is. You can leave that as m or x, whatever you like. Whoops. But I know that when we multiply them together, we get -1. So that means your second gradient is -1/2. So I'm going to write that down. Let's rub that out now because we worked it out. And some of you may have already guessed that without using your calculator. Okay, so, and a point is 2, 5. Okay, so we're using this information and we're substituting it into y equals mx plus c. Now y is 5, so I've put 5 here. M is -1/2. X is 2. And c is what we're working out. So let's just do -1/2 times 2. So that becomes -1. And bring that 1 over. So c is equal to 6. So your equation of the line is y equals, your gradient we worked out is -1/2 x plus 6. Now, just looking at the others, I'm not going to actually do them. Oh, this one looks like we're missing an x. So if you're doing J, just put an x in here. You don't always have to use your calculator, okay? And for some of you, you won't be able to have your calculator if you go on to do methods. And you do need to know how to do this. So let's have a look at question J. Okay, so just add in an X there as well. Okay, so we've got y equals negative 217x minus 3/4. Now this gradient here helps us with what is perpendicular. Now it's negative, so that means our new gradient, the gradient of the new line, M2, is positive, and then you just flip. So it becomes 7 on 2. Now I'll complete this question. So we got negative 8 and 3. And I might go back to blue. Okay, so we have the general equation of a straight line is y equals mx plus c. Substitute those values in, so we have 3 equals 7 on 2 times negative 8 plus c. Now, if you can't do that, use your calculator, but let's test my ability to do 7 times 8, and so I know it's going to be a negative. 7 times 8 is 56 on 2 plus c. 56 divided by 2 is 28. And to get over that side, we add, so it's going to be c equals 31. So my equation is going to be y equals 7 over, I feel like, I just don't like it when I get large numbers because I get paranoid that I've made a mistake. So remember, we have answers. Let's just scroll down all the way to J. Ah, there we go. Such a relief. Okay, so we got that one right. Remember, there's all the working out there for you, but I encourage you to use your calculator, especially if you're just planning on doing further. If you're doing methods, do try to do it by hand as well. And I'm going to stop there because that's a very, very long video.